In this video, we're going to talk about the polar coordinate system. So, we are all familiar with the Cartesian plane, the Cartesian or the rectangular coordinate system. However, we also have other systems, and the reason for studying different coordinate systems is that certain curves are more naturally described in one coordinate system rather than the other. So, the Cartesian plane or the rectangular coordinate system, more or less, that's where we start because it gives simple equations for lines, parabolas, or cubic curves. But for a circle and for other types of curves, it's complicated and it's not a function. In polar coordinate system, circles, ellipses, roses, and figure eights, curves that are difficult to describe given rectangular coordinates, would be easier. So it is more natural to describe a planet's path, for example, around the sun in terms of the distance from the sun and the angle of travel, which are the polar coordinates. So the reason why we're going to study a different system is because it might be easier for other types of graphs or curves to look into polar coordinates other than Cartesian coordinates. So if the Cartesian coordinate system uses a directed distance from a certain origin, the polar coordinate system uses distances and direction to specify the location of a point in the plane. So, for us to form our polar plane, we fix a point called the pole rather, this one, or the origin, and then construct from the pole an initial ray called the polar axis, this one here. Then each point P can be assigned the polar coordinates r or theta as follows. R would be the directed distance from the origin, from the pole rather, to P. So yung haba or that length of line segment OP would be this numerical value that's the first coordinate in your polar coordinates. If R is negative, then P with coordinates r theta is defined to be the point that lies r units opposite. So if r is negative, ito yun. This is where it is. And later on, we're going to have a specific example for that. While theta, the second coordinate in polar coordinates, gives us a angle counterclockwise from the polar axis, just like an angle in standard position in trigonometry. So let's have an example of plotting these following points on our polar coordinate system. So what you can see here is an example of a polar coordinate system. You can imagine this line here. Ito, the line, oops, sorry. Let's make it really fast. There you go. It's more okay. So this line here, this is the pole. Ayan, ito yung pole. This is the pole here. And this line, horizontally intersecting the pole, this is what we call the polar axis. And as you might have noticed, the angles are in intervals of pi over 12, and they are written in radians. So in polar coordinates, at least for this video, for our lesson, we're going to use it in radians. So this is the polar axis. Another line that is usually helpful for us is the y-axis of the Cartesian plane. The y-axis is here, although it's not called y-axis. It's usually called the line pi over 2 or the pi over 2 axis. There you go. Now, we are asked to plot, for example, the point for 3 pi over 4. So, r, remember, is the distance from the pole to the point, and 3 pi over 4 is the angle. So sometimes it's easier to find first the angle. So since it is positive, we have a counterclockwise direction of rotation. So here, easily, we can find 3 pi over 4. Since the radius is 4, so from the origin, this is radius of 1 with angle 3 pi over 4. This is 2, 3, and 4. So therefore, the point therefore, 3 pi over 4, 3 pi over 4 is this point here. There you go. Now, how about if it's negative coordinates? For example, here. And we have here also. Now, since this is negative, negative in the angle tells us that this is a clockwise rotation of the angle. There you go. So therefore, instead of moving counterclockwise, ang galaw natin pa clockwise. That's negative pi over 3. So this is negative pi over 12. Mirror, this is negative pi over 6, negative pi over 4. Therefore, this is negative pi over 3. Clockwise rotation na ginagaya ito. This is negative pi over 3. Now, negative 3 would give us, we have to go to the opposite side. So first, let's look for 3. This is negative pi over 3. That's radius 1, radius of 1 unit, 2 units, 3 units. So this is, if the given is 3, negative pi over 3, this is where it will be. However, since it says negative, we have to go to the opposite. So this is on the opposite end of our ray. So if this is 3, then we have to go back here. 1, 2, 3. Eto. So that point there, this point here is actually the point negative 3, negative pi over, oops, there you go. So this point blue here is the point negative 3, negative pi over 3. Now, try on your own to plot the points in numbers 3, 4, 5, 6. Pause the video and try to see if you'll be able to plot the points given on the screen. So assuming you've paused the video and really did so, let's see what we have. First, pi over 3, 2. So pi over 3 is here with radius 2, 1, 2. So that's pretty straightforward. That this is the point 2 pi over 3. We mentioned this a while ago, negative pi over 3 is here, but since it's positive 3, not negative 3, we don't have to go back to that side. So 1, 2, 3. There you go. So this is the point 3, negative pi over 3. For negative 2 pi over 3, we have pi over 3 here. This is where it is, so negative, so pi over 3, pero negative 2. Instead of here, this is which is 2 pi over 3, we have to go back here, 1, 2. Here we go. So therefore, this is where negative 2 pi over 3 is. If you're, again, just to emphasize, this is if this is positive 2 at counterclockwise rotation angle is here. If it's negative, we have to go back to the other side. So for 4, negative 3 pi over 4, since it's negative 3 pi over 4, we have to start with a clockwise rotation. So negative 3 pi over 4, this is negative pi over 2. So negative 3 pi over 4 would be this one here. So 4, so 1, 2, 3, 4. Here you go. This is now 4, negative 3 pi over 4. So that's how we plot polar coordinates. The thing is, if you might have noticed, because of that system, pwedeng meron pang ibang way or meron pang ibang coordinates na pwedeng i-assign for that specific point. Unlike rectangular coordinates, xy is unique for every point. However, if you're going to notice, r theta and r theta plus 2 pi is actually the same. And I'm going to leave it to you why they would be the same. But because of this idea, so we're going to get more than one or multiple representations of one single point. We can use the negative values of r, and we can use the concept of theta plus or minus 2 pi or multiples of 2 pi. So we can have different representations for just one specific point. Let's have a specific example. So we're asked to plot the point 3, 7, pi over 6 and then find 3 additional polar representations of the point with these conditions. So maybe I'll just do one and then I'll leave the other two to you. So let's first plot 3, 7, pi over 6. So 7 pi over 6 first, 7 pi over 6 is here. Then 3, 1, 2, 3. So this is the point 3, 7 pi over 6. Now we're asked to give another polar representation of this point given that r is greater than 0 but theta is in between negative 2 pi and 0. This would mean dahil in between negative 2 pi and 0, this tells us that we are going to have a clockwise direction because it's from negative 2 pi to 0. So therefore, we have to start from 0 going this way. But r should still be positive, so we remain 3. So if we're going to start counting, this is negative pi over 12, negative pi over 6, let's count. Negative 0, negative pi over 12, negative pi over 6, negative pi over 4, negative pi over 3, negative 5 pi over 12, negative pi over 2, negative 7 pi over 12, negative 2 pi over 3, negative 3 pi over 4, and this is negative 5 pi over 6 by counting. So another way of representing this using using a positive r but a negative angle would be 3 negative 5 pi over 6, having that clockwise direction of the rotation of the angle. So let's have another example. We are now asked to plot the point 5, negative 2 pi over 3 and find additional polar representations of the point such as one of them will have r greater than 0 and r less than 0. So let's work with first where is 5 2 pi negative 2 pi over 3. So negative 2 pi over 3 is somewhere here. It's greater than less than negative pi over 2, but it will not go beyond negative pi. It's negative 2 pi over 3. So which is somewhere here. So since that's 5, so we just need to count from here. 1, 2, 3, 4, 5. Ito. So that one there. This red point here is 5, negative 2 pi over 3. Now, we are just given with the restriction that r should be greater than 0. No other condition. So we can have an angle. It's also positive or greater than 0. So from here, we'll just rotate clockwise to get another angle for this. So if we rotate clockwise, obviously it becomes 4 pi over 3, the angle. So this point can also be represented by the polar coordinates 5, 4 pi over 3, a positive r, and a positive theta. Now, if we would need a negative r, that means the angle should be somewhere here. Then we just, so that when it becomes negative, it moves here. This is 4 pi over 3. If we move to the other side, its opposite, quote unquote, is at pi over 3. So therefore, we can position or use this angle here so that the positive angle is at pi over 3. So to make it negative, we move back there. Therefore, another way to represent this point is at negative 5 rather than pi over 3. So just to show that this is pi over 3, so when you go negative 5, you have to go back here. So those are just some of how we have to, or we can represent a point using different multiple polar representations. Now, now that we're looking into polar coordinates, we also have to look into the relationship between polar coordinates and our Cartesian coordinates. Now, if you would recall, let's say we have let's place it in the Cartesian plane. There you go. Let's say we have this Cartesian plane with x and y axis, and say we have this. Let's make blue as the polar. There you go. And this is point P with the length from the origin O to R. This is angle theta. So, if P would have the coordinates x, y as Cartesian coordinates, let's write it in black, x, y, and it would have also the polar coordinates r theta, how do we relate the two? Now, this is actually a familiar figure because once we draw a broken line here that is perpendicular to the x-axis, then we make this, and we make sure that the perpendicular that we have right angle, we have a right triangle. So based from this, since this is using the Cartesian coordinates, the length of this is obviously x, and the length of this is obviously x, and the length of this is obviously y. So following our trigonometric functions of an angle in a right triangle, we're going to have, for sine, we're going to have following this, sine of theta would actually be equal to x over r. There you go. So if I cross, not sine, but not x rather, but y. Let's change this to y over r. Opposite over adjacent. So that would mean if I cross multiply this, y would then be equal to r sine theta, which is this formula here. Similarly, if we're going to get the cosine of theta, that would be equal to this time x, the adjacent side, over r. And if we cross multiply this, then we're simply going to get x is equal to r, then cosine of theta, this formula here. And we know that tangent of theta would then be equal to opposite side, which is y, over the adjacent side. And finally, from the Pythagorean theorem, where you know that r squared will then be equal to x squared plus y squared. So with simple reasons, forming the right triangle, we can see the relationship between the polar and the Cartesian coordinates. It's the same whether r is positive or negative. With that in mind, we can then convert polar coordinates to Cartesian coordinates and vice versa. For example, if we want to know the Cartesian coordinates of polar Cartesian, we want to know the Cartesian coordinates of the point 2, pi, we just need to use either one of these four formulas. Now, if we want to figure out the Cartesian coordinates, then we need to look for the value of x and the value of y. From the formulas, we know that x is equal to r cosine theta and y is equal to r sine theta. You have r and you have theta. So therefore, the value of x would be equal to 2 times cosine theta, while the value of y would be equal to 2 sine theta. Cosine theta is equal to negative 1, so that's 2 times negative 1, which is equal to negative 2. Sine of theta, which is actually sine pi, that would be equal to 0. So I'm going to have 2 times 0, which is equal to 0. Therefore, the Cartesian coordinates of the point 2 pi is actually at negative 2, 0. Now, if we're going to do the vice versa of that, from Cartesian to polar, we have the point negative 1, 1. Then we need to look for r and then theta. What we have in our formulas is that the tangent of theta is equal to y over x. While for r, that's r squared is equal to x squared plus y squared, given x and y. So first, for theta, tangent of theta will be equal to y, which is 1 over x, which is negative 1. Therefore, tangent of theta would be equal to negative 1. Theta will then be equal to r tangent of negative 1, in which we have the principal value of this inverse tangent function to be at negative pi over 4, which we do accept since we are in the polar coordinates. On the other hand, for r, we're going to have r squared is equal to x, that's negative 1 squared, plus y, which is 1 squared. R squared is then equal to, that's 1 squared, negative 1 squared is 1, plus 1 squared is 1. So that's r squared is equal to 2. Square root, r would then equal to positive or negative square root of 2. Which is fine because we have multiple representations of this of the point rather. Now, for the Cartesian, we are sure that if this is our Cartesian plane, then the point is at negative 1, 1 here. Negative 1, 1. So with that in mind, we just have to make sure that our representation is at the second quadrant. So it's a multiple of pi over 4 what we would have here. So if we're going to use positive square root of 2, that can be 3 pi over 4. Because it is also possible that the tangent of 3, not possible, it is the value, the tangent of 3 pi over 4 is also negative 1. So this is one polar representation. If you're going to use negative square root of 2, then you'd have to go the other way around from here. So that would be, that's negative pi over 4. Starting from here, it becomes negative pi over 4. So this can also be represented as negative square root of 2, negative pi over 4, and a lot more. And if we can convert points, we can also convert equations. So we're just going to use the same formulas. Let's write it down here. Just going to use the same formulas that x is equal to r cosine theta, y is equal to r sine theta, tangent theta is equal to y over x, and r squared is equal to x squared plus y squared. We just use the following to express an equation this time from one point to the another. For example, if we want to express the equation x squared plus x squared minus y squared equals 16 as polar coordinates, we need to refer them here. So x is equal to r cosine theta. Therefore, by substitution, this would then become, let's just copy again the equation. So since x is equal to r cosine theta, y is equal to r sine theta by, in the theorem, to convert Cartesian to polar, this will then become r cosine theta squared minus r sine theta squared equals 16. So, if we're going to simplify this, this becomes r squared cosine squared theta minus r squared sine squared theta equals 16. We can factor out r squared, so r squared is equal to cosine squared theta minus sine squared theta equals 16. And if you notice, since I factored out r squared, this actually becomes a trigonometric identity that we can shorten. So therefore, this becomes r squared cosine 2 theta equals 16. Therefore, the polar form of this Cartesian equation can be r squared cosine 2 theta equals 16. And if we're going to do vice versa, we're going to express this polar equation into Cartesian or rectangular form. We just need to follow our formulas that we have for conversion. So since we have this one here, we can relate again all four. Although r, that would be the square root of x squared minus y squared, we have a cosine theta here. We have a cosine theta here, which is actually something that you can use, but it might be a bit difficult. What do I mean? If I'm going to replace this immediately with, since r squared is equal to x squared plus y squared, then r would be equal to positive or negative square root of x squared plus y squared. This is a bit difficult to work with. So instead, maybe we can make it easier if we cross multiply first. In doing so, we're going to get r times 1 minus cosine theta equals 2. Therefore, we're going to have r times r cosine theta equals 2. This is easier to convert to Cartesian because that this value is already, this value is already x. While r is our positive or negative square root of x squared plus y squared. And since this is an equation in radical form, let's transpose this here. So I'm going to have positive or negative square root of x squared plus y squared is equal to x plus 2. So that we don't have any radicals, let's square that. And I'm going to have here x squared plus y squared is equal to x squared plus 4x plus 4. So therefore, if I transpose everything on the left side, I'm going to have x squared plus y squared minus x squared minus 4x minus 4 equals 0. Simplifying, combining like terms, therefore the rectangular form or the Cartesian form of the equation is y squared minus 4x minus 4 equals 0. And those are the concepts behind the polar coordinate system.